Hello, my name is Aline Vale. I'm from Fortaleza in Brazil, and I'm here to present the paper called Evaluate the New Approach for Characterizing the Performance of Phosphate Binders through the Multiple Stress Creep and Recovery Test. Here we have the structure of the paper, which is divided by the introduction, the materials, the standard MSCR test, the uniaxial repeated load test, the new approach for the MSCR test, and the conclusions. It is important to point that one of the main distresses that occur on asphaltic surface layer is the permanent deformation, and it can be caused especially by the traffic load and the high temperatures. Here in the city of Fortaleza specifically, we have a tropical weather, which is favorable for the occurrence of permanent deformation on asphaltic pavements. To analyze the mechanical response of the materials towards this distress, we have to analyze not only the mixture, but also its contents, the binder and the aggregates. For this paper, we analyzed the binder's response with the MSCR test and the mixture's responses with the uniaxial repeated load test, which provides us the flow number value. But the main objective of this paper is to evaluate the new approach of MSCR test and its new parameters proposed by Moreno Navarro in 2019. And in Brazil, the national standard for this test protocol is still being implemented, so new inputs and reviews are welcomed at this stage. This table shows the binders and aggregates used for all the mixtures of this paper, and it's important to point that M4, mixture M4, has fly ash addition to the aggregate grading curve. The aggregates and binders used for this research came from different origins, including different refineries over the countries, and we had the contribution of different universities over the whole country. The standard MSCR test was done following international standards, and we obtained with it the parameters of non-recoverable compliance and the percentage of recovery for each binder. We have here binders analyzed on its performance grade temperatures, and according to those temperatures and the values of non-recoverable compliance, we only have indication to use binders B1 and B2 on a standard traffic load. With the percentage of recovery, we can identify that binders B2 and B6 have better response when it comes to permanent deformation on every tested temperature. The uniaxial repeated load test was performed according to Brazilian standards, using the temperature of 60 degrees Celsius and the vertical stress applied of 204 kPa. With that, we obtained the flow number values for all 8 mixtures. We have here the classification according to the traffic volume for the 8 mixtures following Brazilian standards. And if we analyze closely, we can see here that mixtures M3 and M4, we can observe that the addition of fly ash to mixture M4 resulted on a better mixture when it comes to distress of permanent deformation. If we analyze here mixtures M2 and M8, we can see that the lower non-recoverable compliance presented on binders was on the binder used on mixture M2, and the higher recovery percentage occurred on the binder used on mixture M8. So it is comparable to the binder results, the flow number results. If we analyze mixtures M1 and M6, we can observe that binder used on mixture M1 had lower non-recoverable compliance and higher recovery percentage, which is good for permanent deformation. And the result of flow number values also showed that tendency for the mixtures. On mixtures M6 and M7, different types of aggregates were used in the same binder. We can see that the aggregates also have influence on the final results of flow number values and on the response of the mixture for permanent deformation. For the new approach for the MSCR test, we can see that the testing protocol was different from the standard testing protocol. It uses the same stress for every cycle. And besides the standard parameters of non-recoverable compliance and percentage of recovery, Moreno Navarro also proposed new parameters to evaluate the performance of binders. We have here the results of non-recoverable compliance and the recovery percentage, and we can identify that they are similar to the standard method results, and binders are classified at the same traffic volume indications. So it's similar. Here we have the non-recoverable strain rate and the average recovery strain for different temperatures. And it is important to point that the average recovery strain can relate good with the recovery percentage. Here we analyze the recovery capacity for every binder on different temperatures. And those parameters we've seen till now lead us to the flow index and the temperature index. And those are very important parameters. We can identify here that for binders B2 and B6, the flow index are higher, and it indicates that they have higher capacity of absorbing energy without deforming. And the temperature index only leads us to the fact that these two binders are more susceptible to temperature changes. It doesn't mean they are bad. It just means that they change behavior from 58 degrees Celsius to 82 degrees Celsius more than the other binders. Here we have a figure that was provided by Moreno Navarro in 2019, and it shows how the parameters were developed and what they represent in terms of tendency to deform and recover. It is important to point that even though this research focuses on binders' permanent deformation, results confirm the tendency obtained by Moreno Navarro, showed here in this figure. As conclusions, first we saw that the non-recoverable compliance and the recovery percentage were similar to the MSCR standard test, so they can represent the material's properties just as well. And analyzing the non-recoverable compliance for binders B4 and B6, They were similar to the difference of behavior observed on mixtures M7 and M8. If we analyze the behavior of binder B2 and mixture M2, we can also see that the aggregate's choice can have a great influence on permanent deformation. With the flow index and the temperature index, only for the aspects of permanent deformation on the binder, we can analyze whether the binder is more or less susceptible to temperature variation. We can analyze if it absorbs more energy without deforming, and which binder has a higher recoverable deformation. Here we have all the parameters used to the binder's analysis, and the new parameters can explain more of materials' properties. However, the existing parameters are still efficient on binder selection. So, since the new approach has more explanation about materials' properties when it comes to distress of permanent deformation, it is indicated to be used on binder selection, especially because it has a simpler testing protocol. The path to obtain the parameters is also simple, and it can be helpful on preventing occurrence of permanent deformation. And it could easily be implemented on Brazilian standards at this time. Now, I want to thank all my partners on this paper, Professor Jorge Soares and Professor Jusceline Bastos, and the universities and companies that funded this research and provided materials. Also the research team, including my colleagues and the laboratory staff. Thank you.